diagram, the basic thing is when we face two events happening one after one, two events one after one. In those cases, we are going to represent our given data in tree diagram to find the resultant probability. For an example, you are spinning. You are going to spin two coins. Two coins. No, not two coins. One coin two times. You're going to spin one coin and note what is the results you receive. Then after you should again repeat the procedure again to receive another result. For that, there are two possibilities. When you think about an unbased coin, unbased coin means the probability of getting head and tail both are same. In those case, first of all, in first attempt you are going to spin the coin to receive some results. In that we can indicate that in tree diagram like this. There are two possibilities. One should be head. One should be receiving head. Another one would be tail. Head and tail. These are the two results we can obtain by as our result. So to getting a head, the probability would be 2 upon 1, because there are only two um, flat surfaces on that unbased coin. That means one is head, one is tail. So among these two, getting head, that would be 1. From these two possibilities, our probability would be 1. So getting a tail, that would be also 1 upon 2. Then after, again you are going to spin the same coin again. This is your second attempt. Second time you are going to spin the same coin again to receive your results. For that, here also there are two possibilities. Head and tail. Here also head and tail. Why we expanded our branch? Tree means there are some branches, no? So there is a branch. Again, I expanded each branch twice. Why is that? Because when you receive head first, in your first attempt, you receive the head. Again, also you can receive head or tail. If you receive tail in your first attempt, second attempt, we don't know what will happen. Sometimes head, sometimes tail. So for that also we have to indicate our probability. So here also there are two outcomes among these two. Probability of head, that would be 1 upon 2, tail also 1 upon 2, head 1 upon 2, and receiving a tail, that one also 1 upon 2. This is the way you should complete the particular probabilities in each branch. In each branch we have some possibilities. In those possibilities, from that possibilities, these are the two possibilities. From that, to receive head, the probability will be among these two. One is the probability belongs to H. Likewise for tails. Again, why we expanded twice again? Because you should know the reason. Because we can receive first head, second head. That's also possible. First head, second tail. That one also possible. We don't know what will happen. First tail, second head. That one also possible. And tail also possible. This is the way you should expand your tree diagram for the given data. Then after, we are going to find the probabilities. Probabilities for, let's see. Now let's see. My question is to, first my question, find the probability of getting head and head. Head and head. First case. In your first attempt you should receive head, and in your second attempt also you should receive head. Likewise, you have to find the probability. For that, you should think about first head. First head means this one, second head means this one. So this is the these are the branches we have to concern about. Head and head. In both cases we are going to receive heads. No. So this is the probability. There are 4 events happening here. One is head and head, then head and tail and head, and tail and tail. Among these 4 events, what we need is, in both cases we are going to receive head. So you should multiply half. Half. From this branch we expanded another branch. So you should multiply half into, so this one also the probability, that would be half. No, half into half. So finally 1 ones are 1, 2 twos are 4. This is the probability of getting. In both cases, when you receive head, this is the belongs probability. Okay, this is the probability according to the our requirement. In both cases, heads. Okay. Then in second case, let's find first tail. Okay, first tail comma second head. Okay, we are going to find the probability belongs to this requirement. For that, the same thing you should follow again. Okay, tail, first tail and second head. So this is the branch. Okay, this is the branch what we need over here. So it would be half into half. First of all, getting a tail, half. Secondly, getting a head, that would be half again. So half into half, that would be 1 upon 4. 1 upon 4. That's going to be a final probability in this case. That's all. In both times, different outcomes. That means if I think about this branch, okay, we cannot think about only think about this branch. Okay, these are the four possible events: head, 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 tail, tail, head, tail, tail. Okay. Likewise, first even head and head. But in both cases, we are receiving same outcomes. Okay, in both cases, we are receiving head now. So this is not our requirement. When you think about this instance, first case head, second case tail. So we are receiving different outcomes. That means H, head and tail. Okay, this is what we need. Then after, let's think about this tail and head. In this case also, we are receiving different outcomes. Okay, first tail, second heads. Okay, these two are not same. Okay, first head, second tail, and here first tail, second head. Okay, here we need this one also, tail, head. When you think about last event, both time tail, that means both outcomes are same. We don't need that outcome as well. So we need only these two outcomes. Okay, head and tail and head. That means in both times different outcomes. So head and tail means this. Okay, you should multiply half into half. Okay, half into half. With that, you should add our next probability. So here also tail and head, that would be half into half. Half into half. So to finalize your answer, you should multiply first. So 1 ones are 1 upon 4 plus again 1 upon 4. Why we are adding these two? Because there are two occurrence. Okay, there are two occurrence of in both times different outcomes. First head and tail, second tail and head. Both are possible, no? So we found each event probability separately. So this one would be 1 upon 4. Here this one also would be 1 upon 4 again. So to finally get our outcome, there are two such events. So to finalize our answer, we have to add these two outcomes. So 1 upon 4 plus 1 upon 4, that will be 2 upon 4. Okay, that will be 2 upon 4. You can finalize your answer as 2 upon 4. 2 upon 4. Yeah, we can simplify this now. So we can simplify our answer to write it as 1 upon 2. 1 upon 2. You can express your answer as 1 upon 2. Okay, 2 upon 4. Either 2 upon 4 or 1 upon 2. Both are same. You should understand why we are adding these two probabilities, because there are two occurrence of receiving different outcome. These two. So we found each of their events probabilities separately. When we add up them together, we will receive our final answer. Here our requirement, which is at least one tail. Okay, our requirement would be at least one tail. To find that one, what do we need to do? For that, we have to think about our all events. Okay, here the probability that's telling H and H. Okay, head and head, head comma head. That is our outcome. Here there is no any tail. Okay, there is no any tail. So we don't need this probability. When you think about this instance, we are receiving a head and tail. At least one tail. At least one tail means here we are receiving at least one tail. Okay. In your class, your principal came and asked the students who received at least 50 marks in maths, just hands up. Okay. At least 50 marks in maths subject, just hands up. So in that case, the students who received more than 50 also can hands up. Okay, try to understand what I'm conveying. Okay, students who got 50 marks, just hands up means the students who received more than 50 marks also can hands up themselves. So likewise, here we need this probability. Here also tail and head, we need this probability. Question is asking at least one tail. No, at least one tail. That means here they are receiving two tails. That means here at least one tail also happening here. No, two tails means at least one tail included in this condition. So you should multiply half and half. So it should be 1 upon 4. Here also 1 upon 4. Here also 1 upon 4. We need these three probabilities. Okay, we need these three probabilities. To finalize some answer, we have to add up all these three. 1 upon 4 plus 1 upon 4 plus 1 upon 4. So it would be 3 upon 4. That should be our outcome in this case. Here, our requirement is exactly one head only. Okay, let's see. Exactly one head only means here there are two heads. No, your principal came to your class and informing that the students who obtain 100 marks just hands up. Okay, 100 marks just hands up means only the students who got 100 marks can only hands up. Okay, if you received 99 marks, you cannot hands up in that instance. Likewise, yeah, only one head. Okay, only one head means two heads not applicable. If my question is at least one head means 50 marks. Okay, likewise 50 marks. So the students who received more than 50 also hands up. But in this case, one head only 100 marks. So the students who received only 100 marks can only hands up. So here there are two heads. No, we need only one head. That means two head. We don't need two heads. So we can reject this even. So here it's possible. There is a head. No, only one head. Here also only one head and one tail. Here there is no any heads. We don't need this one also. So when you find the probability, so it would be sum of 1 upon 4 plus 1 upon 4. Finally, it will be 2 upon. That should be your final answer in this case. Exactly one head only.